So in this section of 11.4, we're going to be finding and applying the discriminant. So let's first understand what the discriminant is. So the discriminant is a part of the quadratic formula. And so the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. But the discriminant is what's inside of the square root. So we call that the discriminant. And the reason why is it tells us how many x-intercepts there will be. Okay? And so if we look at the three cases, the first one is b squared minus 4ac greater than 0. That basically means that the b squared minus 4 will be a positive number. And you're going to get two solutions. Okay? Because in that case, we're going to get two solutions, so then we'll have the plus and minus that we'll be dealing with. So that's the reason why we're going to get two. The second case is where b squared minus 4ac equals 0. Basically, that means that we get one solution, because the square root of 0 is just 0, and so all this, like we saw before, goes away, and we don't need the plus or minus, so that's why it's a one solution. And then our third one is b squared minus 4ac less than or equal to 0, which means we have no solution. And that's because, like we saw before, that the graph, the parabola, does not intersect the x-axis. So intersect the x-axis. Okay? So these are the three cases that we deal with. And so if you look at the book, and I'm on page 772, it shows the three cases and even a nice beautiful visual of what they look like. So here it is where you have a negative, which is less than 0. So the only numbers that are negative will be less than 0. That just tells us, oh, you're not going to get any solution. And so that's why. So it's either going to be a graph going downward or a graph going upward. The same thing goes for the next case. We get one x-intercept because the parabola just touches the x-axis at one point. And so that's why you get one solution. And then when you have a positive, which is greater than 0, then you're going to get two x-intercepts. So here are the two different pictures of what that would look like. And so let's take a look again at using the discriminant. Okay, so let's do that. So let's say I have another problem, and it is 4x squared, and that's plus 25 equal to the 20x. Well, I want this equation looking like ax squared plus bx plus c equal to 0. I don't have that here this time. So I need to move the 20x to the other side, and then this side on the right will be 0. So that's what I'm going to do. I'm going to minus 20x to both sides. So then I get the 4x squared minus 20x plus the 25. And so now I know my a, my b, and my c, which is 4, negative 20, and 25. Now before I put this all into the quadratic formula, let's do the discriminant. and see how many solutions we get. So b is negative 20 squared minus 4 times 4 times 25. So this is 400. This is 100, and that gives me 400. So I get 0. This tells me I get one solution. So that's all it tells me. It doesn't tell me the answer, what is the x-intercept, but it kind of makes it easier to do the quadratic formula, because now I just have to, if I have this set up, I already know this part, so I can put that in immediately. So I got negative of a negative 20 plus or minus 0 all over 2 times 4. See, now this just makes it so much easier. I don't have to put so much stuff in because I've already done what was inside the square root. And so x is equal to positive 20, right? Because it's two negatives, and then I have 8. And so x is going to be what? I could simplify this by dividing by 4, right? So this is really 5 over 8. I'm sorry, 5 over 2. 5 over 2. Okay. Or we could say it is 2.5. Okay. So much easier to solve the quadratic formula. So I like the discriminant because it tells me right away what I'm looking for. I should get only one solution, which is what I did. And so my final x-intercept is 2.5 comma 0. Now remember again, that's all I find in this thing is the x-intercept. That's all. The only purpose of the quadratic formula is to find the x-intercept.